Hey guys, welcome back. So today, as part of the iOS hacking and security research tutorials playlist on this channel, I'm going to be making a video covering return-oriented programming and basically doing a complete walkthrough on how to write a ROP chain exploit for a very vulnerable program. So this is not going to be as vulnerable as the other programs. It's sort of a more real-world suited application, so it's good practice if you're interested in the future on developing exploits for real-world cases or even iOS jailbreak exploits. So this should be good practice, and ROP is definitely one of the fundamental things that you will need to learn to be able to basically succeed in modern exploitation techniques, because it basically is a way of getting around the non-executable stack, non-executable heap. So it's an alternate way of gaining arbitrary code execution. So if we look up the definition for return-oriented programming, you can see that return-oriented programming is a computer security exploit technique that allows an attacker to execute code in the presence of security defenses such as non-executable memory. So normally, I'll do a quick overview of that. Let's say you have something like such as the iOS kernel. You will have the kernel code, so the actual assembly instructions. These will be marked as read-only and executable. So obviously the device needs to execute these, but they're read-only, so they cannot be modified. Then you have other areas such as the stack or the heap, which need to be modified at runtime for the program to actually store variables and to modify things. But this area of memory is marked as non-executable. So basically you can never have a piece of memory that's marked both executable and writable, because if that's the case, then an attacker can find a way to write their own code into the program memory and then just execute that. So return-oriented programming is basically a way of getting around that by reusing code that already exists in the actual application. So we're going to use parts of the code and sort of chain it all together to achieve a different outcome that the application was never actually intended to do. So that's basically how return-oriented programming works, and all jailbreak exploits, pretty much every jailbreak exploit that's ever been released uses ROP, because on iPhones you do have this non-executable memory, so you cannot just write a shellcode payload and jump to it. So you need to write completely in ROP. So that may sound a little bit complicated, but hopefully this video will go over the basics on helping you guys understand it and explaining completely how it works. Now, if you want some more background knowledge before watching this video, then I recommend going to my website. And on this website, I have free tutorials currently on exploitation development for the ARM platforms, and the last tutorial is actually using ROP gadgets, which is basically what I'm going to be doing today in this video. So if you want a written version of the tutorial, then read through this. If you're completely new to exploitation, then make sure you check out the other videos in the iOS hacking and security research playlist. But yeah, so once you've watched all that and once you're up to date, then ready to go ahead and get started. So you can probably tell just by the length of that intro, this video is going to be quite a lengthy video, and that's just because I'm going to go completely in depth on exactly how this works, so that it's clear enough for a beginner to understand this video and be able to actually write their own exploit after watching it. So hopefully you are ready to get started with this. So today we're going to be exploiting a program called Xylex, which is something that I wrote just as a sort of a simulation of a vulnerable system or vulnerable application. Some of you guys may remember the name Xylex. It's for a tweak I built back in 2015 but never released, so I'm actually using the name for something different now. But anyway, let's go ahead and get started. So on my Mac, I have my iPhone 4. I'm going to SSH into it. So you can do this from the device itself if you want to on mobile terminal, but for viewing purposes, I'll do it on the Mac so you guys can actually see it a bit clearer. So just SSH in, log in as root, and we're going to CD into my developers directory. Now, down below in the description, there'll be a download link for Xylex, which, as I said, is the program we're going to be exploiting. I have it right here on my Mac as well, and it's just a 32-bit ARM v7 executable file. So it's a 32-bit application, no need to worry about any 64-bit stuff like that, so should just be similar to the ones we've already demoed on this channel. But yeah, so I'm basically in this video, I'm going to be walking through as if I don't know what this program does, just to give you guys an insight of what a hacker would have to go through in terms of reverse engineering and studying how the binary actually works before being able to exploit it. So Xylex is the program to run it. I've got it installed in this directory on my phone, so we're just going to do /Xylex, enter that, and you can see it's going to start the program. So we get, first of all, Xylex version 1.0, start in Xylex. It gives you the stack address, which may be useful later, and then we get this little Xylex title in ASCII art, and then we get a prompt to enter a username. So as I said, it's sort of a simulation of a vulnerable system. It's not really got any real use, but there is a login area to it. So we're just going to attempt to log in. So let's just do a username. We don't know any usernames. Just put Billy. Enter. No user is found with that name. So we don't really know where to go from here. Let's just open it up in Hopper Disassembler. So I've actually already got it there, but I'll show you how to do it. So we're going to open up Hopper, or you can use any other disassembler program. You can use IDA, you can use GDB, you can use Radari 2, anything like that. I'm just going to drag the executable in here, and you can see it recognizes it as a Mako ARMv7. Make sure you select that instead of raw binary, and then click OK, and it will disassemble it for us. So first of all, we want to go and find the main function just so we see what this program is actually meant to do. So here's main. This is obviously the start of the program execution. This is what happens first, or after the start function, but yeah. So you can see it goes through, and we see the prompts, the printfs, which obviously display the stack and the start in Xylex and the ASCII art. And then we get to this username section, which is what we really want to find out how to use. So you can see we see this string here already, guessed. So we're just going to assume that this is one of the usernames. So we're going to run Xylex again, and we're going to place guess in the enter username, enter, and there you go. You can see we're through just by looking at that string. So if someone had never seen this program before, could have found out one of the usernames just by doing that. So now we're on a different screen. It says welcome, and then we have three options. We can display the system version, we can open a file, or we can exit the program. So let's just see what happens with this system version. You can see one, it prints out the system version and then exits. The open file option seems quite interesting, and an exit obviously will just close the program. So we're going to attempt to use this open file section. Now first of all, we do actually need a file. So let's just we're going to use printf hello, and then we're going to use this symbol followed by a file name. So it's called hello.txt. And what that does is it puts this text into a new file called hello.txt. So if we ls on this directory, you can now see we have hello.txt, and if we open it with cat, you can see it does have hello inside it. So we should be able to open this file no problem using Xylex. So let's run Xylex again. Start in Xylex, enter username, we'll put in guest again, and then this time number 2 for open file. It says please enter the path to a file. So we're just going to do, as it's in the same directory, we'll do /hello.txt. And there you go. So we get hello. I'm not really sure why we get these question marks, but it does open the file and print out the contents of the file. So what we want to do with this program is basically exploit it for fun and try to redirect the code execution to somewhere else to be able to do something completely different. So we're going to start by doing some simple fuzzing on parts of the program that we may be able to fuzz. So let's run it again, and we'll start by fuzzing the username area. So we're just going to put a bunch of A's just to see if we can cause a crash or any sort of overflow. So we'll enter that, and you can see it just says no user found with that name. So this has probably got some sort of bounds check-in, and it's actually protected, so can't really do anything with that. So there's not really much other input that we get. The number we could try to overflow. Just get invalid number, no crashes or anything like that. The program just exits normally. So there's no really kind of standard overflow or any sort of exploit or vulnerability that would stand out as I've demoed in the other previous videos. So this is why this is sort of a more real world suited application. As I said, it's still not completely real world. Obviously real world ones will be so much more advanced than this still, but this will give you a bit of an insight into it. So here is where being creative with your vulnerability discovery and fuzzing comes into play. So we cannot just simply enter data through the keyboard to overflow or crash the program. So we need to think of another way we could possibly do that. And then the only way that really stands out with this program is the open file feature. Obviously this feature will open a file that you give to it. So we're going to try and supply a large file rather than a large text input. So to create a large file, we're just going to use the printf again, and actually we won't use printf, we'll use perl-e prints a. Now what we can do with this is times this character by whatever number we want. So let's just do 700. We want 700 A's. Not sure why there's an L over there. So this script is basically going to print out 700 A's, and we want to put that into the hello.txt file. Actually, we'll just do a new one. Hello, no need for txt. Now, if we cat hello, you can see it contains 700 A's. Now, if we supply this to the program, we're going to see what happens. So just type Xylex again to run Xylex, log in as guest, and then 2, and this time hello, not hello.txt. And now we can see we get a segmentation for 11. So that means that something caused a crash in the program, and it's most likely due to the fact that this file was too big for the program to be able to handle. So we just want to see the reason the program crashed. So as usual with any kind of fuzzing crash, we want to examine the crash report. So we're just going to look at this, and you can see in the register section that we do indeed control the PC with the A characters. So by now you should understand what this means if you've watched my previous videos. If you don't understand what this means, then make sure you go back and watch the other videos in this playlist, as well as the videos on my second channel, which explains things more in depth. So basically we have control of the program counter, meaning we can redirect the execution flow of this program anywhere just by running this file. So we want to actually find exactly where we control the program counter. So this time we're going to do a patterned input. So we're going to print F, and instead of doing just A's, we're going to do 4 A's, 4 B's, 4 C's, so on, quite far into the alphabet. So let's just do up to here, up to K, and then we want to put that into our hello file, and then once again run Xylex. Now this time we get it to crash again, but now when we view the latest crash report, what you'll notice is that instead of seeing the A's, the 4141, we should see the hex equivalent of whatever character we are on when it overwrote the program counter. So you can see now the PC contains 46464644. So if we count along, we know that 41 is A. So 1, 2, 3, 4, 5, 6, F, 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 F. So here exactly is where we need to place our address that we want the program to jump to. So we've got this amount of junk characters followed by our malicious address. So now that we've identified the vulnerability in this program, we need to figure out a way to exploit it. Now, this is not just going to be like the other programs I've showed on this channel where you jump to a single function called winner or secret or something like that, and then you're done. This is going to be a little bit more complicated because we're going to be using return-oriented programming, as I mentioned at the start of this video, and the whole purpose of this video is learning how to use ROP gadgets. So to do that, we first of all need a few addresses. So we're going to use Hopper again. We're going to go back in here. Now we want to note down a few useful addresses. So first of all, what we're going to be trying to do is, instead of the program just reading out the file, when it reads out the file, we want to cause the program to print out the uname-a command. So the result of the uname-a command. Now you can actually choose any kind of shell command you want to produce, but this is going to be a proof of concept that we can get the program to execute a shell command of our choice. So to do that, we need an address of the shell command, like the string of the shell command. Now, in real-world situations, you probably won't get the string just liner in the binary. For example purposes and for this video, I've actually left the string in the binary. So you can see in the labels section, you can see this str1, and at this address, if you read downwards, you can see it is uname-a. So if this command was executed as a shell command, it would basically do this. It would give you the information about the device. So we want to use this address, so we need the starting address of this string. So we're going to note this one down, C040. Let's just copy that, and we're just going to put it in here. So we're just going to place that address, and we're just going to label this as uname-a string. So we have our, we don't need to save this actually, we have our uname-a string. So this is the string we want to execute. Now to execute a shell command, most of you will know, if you know Objective-C or C, that the most efficient way to do that is using the system function, which is built in, and you can just pass the shell command and it will execute it. So to do this, we need an address of the system function. Now lucky enough, this program uses the system function, so the address is in here somewhere. Now you can see system right there. You can see it right here. Now we don't actually necessarily have to use this one. We can actually branch to a place in the program that calls system for us Therefore, we don't have to worry about any kind of library randomization or anything like that. So if we go into the main function again, and if we quickly look through here, you can see it sets up the stack and it does a few things up here, and then it branch with link to system. Now this has got some other things on the start of it, but this is the system function. So we can either jump directly to where it branches, or we can jump to here, which will then branch to it to call system. So we're just going to do it the simple way, and we will note down this address, BB98, and that is our system address. So we just got that here as well. So we've got the uname, we've got the string address, and we've got the system address. So all we need to basically do with this is you want system to use this string and basically execute it. That way we'd get the output that we wanted. Now to do this, we need to use something called a ROP gadget. So before you can look for a ROP gadget and use one, you need to understand what it is. Now if you're completely new to this and completely new to exploitation and ARM assembly, then I highly recommend watching this video before continuing with this one. This is basically covers the basics of return-oriented programming. It explains what a ROP gadget is, and it tells you how to exploit my other example program, ROP Level 1, which you can get on my GitHub page. This is a very simple example of ROP. It's a little bit simpler than the one we're doing right now, but this will explain what a ROP gadget is. I'll try to briefly explain it as well right now. Basically, a ROP gadget is a small sequence of instructions being a single line of assembly. So we want a small sequence, so maybe like 4 instructions that do a particular thing and then return. Now the return is very important. If it doesn't return, it's not a ROP gadget. You need to have a return at the end of the sequence of instructions. Otherwise, you cannot chain them together. So if you, as I said, if you want more explanation on this, then watch the video here because it explains how the chaining works. So we need a gadget. In our case, we need a gadget that's going to allow us to set up this scenario where we want to call system with uname-a. Now, if we look up the system command, you can go on the Linux manual page and you can read up about it. And if you do enough reading, you'll realize that in the low level of this command, when it's actually called, it expects the string to be executed to be located in register 0 or R0 on ARM. So if you're doing this for a different platform, then this may be different. And in fact, I think on a different platform it may be pushed on the stack. But for ARM, we need this string, the address of this string, so we need this value here to be inside of R0 before we call this. If we call this without anything being in R0, it's going to attempt to call whatever is in R0, and it's basically just going to crash or fail because there's not going to be a valid string inside of R0. So the gadget we need to find for this program is something that's going to be simply just to put a value in R0, a value that we control in R0. So for the purpose of this video, because this binary is quite small, you wouldn't really find many useful ROP gadgets, so I've actually planted one in a separate function. This function is called gadget. So you can see gadget, and then we have a single line. Now this is a very simple function. This is the gadget. It's only one line, and it does something as well as returning. So this is sort of combined return instruction and a gadget. So normally you'd want a few instructions followed by a return, but this does it all for us. So you can see we have at this address pop R0 PC. Now pop is an instruction used to take values off of the stack. So we control the stack, as we already noticed, because of our vulnerability we discovered. We managed to crash the program by overflowing the stack. So we control what's on the stack. Now if we put a value for R0, which we want to be the string address, and then if we put the PC value as the system address, what it's going to do is it's going to pop the value that we've placed for R0 into register 0, and then it's going to pop the address of system into the PC, which will then call system, and then this will be set up completely so that system will execute our shell command being uname-a. So that may sound a little bit complicated, but hopefully you guys will understand it when I actually show it in action. So what we're going to do, back inside of terminal, we want to first of all jump to our gadget because we don't want anything else to happen. We want the gadget first because that's going to set up the rest of the exploit. Now for it to jump to the gadget, obviously we remembered we need to have it at the place of the FFFF. So everything before the FFFF we still need as junk characters. So we're gonna create our new file, which is gonna be called exploit. So we're gonna place these junk characters, and then after that we need the address of the gadget. So we didn't note this one down yet, but it's BB74. So we're just going to put this here, address of gadget, BB74. Now, as you should know, this is a little endian platform, so we need to write this in reverse order. So we're going to do \x for a hex value, 74 BB, and then we need the other leading zeros, and there, so we have our gadgets. So basically, so far what this exploit string would do is jump to the gadget and then crash because nothing's happened after the gadget. But what we want to happen after the gadget is for system to be called. Now for that to happen, remember when the gadget is executed, it's going to look for the next values on the stack. It's going to put one into R0 and put one into the PC. We need these values to be the string followed by the system. So in the string, the next values we want to put are the string followed by the system. So first of all, the string C040. So we just basically continue again in reverse order, 40 C00000, and then finally the system address. So 98 BB 0000, close speech marks, and then push this into a new file called exploit. Done. So there's the exploit file created, and you can just look at it if you want with cat. So you can see we have our junk characters, and then we have some question marks because it doesn't really have to display some of these bytes. But there you go, there the exploit string is created. So if this works successfully, what should happen is when we select this file for Xylex to open, Xylex, instead of crashing or segmentation faulting, it should basically just call the system the uname a command, which will print out the system information. So we're going to give it a try. We're going to put it in action. So let's once again run Xylex, /Xylex. Xylex is going to start. We're going to log in again as guest, and then we're going to select 2. And now this time, instead of the hello file, we want to run our exploit file, which is our maliciously crafted file. So we're going to type /exploit. And there you go. You can see the exploit did work successfully. We get the output equivalent of if we typed uname-a. So you can see if we just type it in the terminal, we get the exact same output. But just by running this file, we've managed to take full control of the program and do whatever we want it to do. So obviously with ROP there are unlimited possibilities. You could chain together more events. That's why the return instruction at the end of a ROP gadget is very important, because you can basically have an unlimited amount of events happening and just hijack the program completely, do whatever you want with it. So this is just a very simple example of ROP. As I said again, quite similar to the one showcased in this video, but slightly more real world situations. So if you have any questions about this, then leave a comment. I know there's probably a lot of information in this video. Some of it may be hard for you to understand, but I'll leave links to all of the relevant videos that should help you understand this and help you get started. Again, subscribe to this second channel if you are interested in these kind of more advanced tutorials, because there's already a few on here about exploitation and development. So this should help you out get started. But hopefully you guys enjoyed this video. The link to Xylex will be in the description if you want to actually try this exploit out yourself. Hopefully this has given you more of an insight to what real-world exploit development and discovery is all about, because most modern systems today are definitely not going to allow you to overflow a buffer by entering text. So you're definitely going to need to be more creative with your ways of fuzzing and the methods of causing crashes and exploiting systems. So this is just a very simple example. Although it's more real-world based, it's still not, there's nowhere near as advanced as real-world applications, but hopefully it will give you a bit more of an idea about what it is like to develop an exploit for a real-life system. So hopefully you guys enjoyed this video. If you have any questions or queries about this, then either leave a comment or talk to me on Twitter, and I'm happy to help with any issues you may be having with it. But yeah, so thanks for watching. Don't forget to subscribe for more, and I will see you next time.